Today is the 23rd of May 2024, and this will be our 7th video on probability revision. Okay, thank you everyone who have subscribed to our channel. Okay, if you haven't subscribed, please subscribe and then help us share, like, and follow. Okay, and if the account is not yours, please ask permission from the account holder. In the comment section, you normally see follow my notes/script. Please do follow it. Okay, today our starter is still mental maths, and then we'll do the tree diagram. At times root 2, root 2, root 3, root 3. Instead of it coming across as root 3, root 3, when I'm rewatching, at times I hear root 3 times 3. Please, if it's root 3 times 3, follow the notes. If it's root 3, follow the notes. Please, strictly follow the notes, because these are my notes. They are very accurate. Beware of scammers, please. That is all I'll say about that today. Okay, recap. Watch last video for recap. We've been looking at all the types of probability questions you can get at this stage, and I'm trying to help make it easier for you, so that when you go and you see the word then like it was replaced, not replaced, in this order, not in that order, at least one, at least two, you will know what to do. If you have to represent it on a tree diagram, you know what to do. Okay, unfortunately, we can't continue doing a revision of probability. We have to go and do something else. So I'll just stop maybe with this video or another one, and then try and bring it, if I get more questions, try and bring it in some possible questions if I'm doing the next set, or just bring it to the starter if it's not a lot. Okay, we don't want to get longy starters. Okay, otherwise it is into what I want to share with you. Okay, now watch last video for recap. All is about probability. We did more probability questions. Represent on tree diagrams. We use the or and end law combined. Okay, we know that when it's or, we add, and when it's end, we times. Okay, at this stage we should be able to be putting, because if you can set that up, then everything else is calculation. But if you can't start from that stage, then you are not going to get to the answer. Okay, so you need to understand the question, start on the right, set the right stuff in place, and then continue from there, and then the rest is calculation, and then you get the answer. Now let's look at sets. Okay, today the square root of 1,000 times 10. Now 1,000 can be written as 100 times 10, and then we have another 10. Okay, root 100 is 10. 10 root 10 root 10 is another 10. So it's 1,000. So square root of 1,000 times 10 is 100. Okay. 2. Square root of 3 divided by 3. So in this form, I can write it as this form. Now the root 3's will cancel out. So I have 5. In this form, it will be difficult to see unless you do 5 divided by 1 and then root 3 divided by root 3. Okay, so I rewrite it in this form. Okay, but if you can see 5 divided by 1, which is 5, root 3 divided by root 3, which is also 1, then you end up getting your 5. Now, 25 root 6 divided by 5 root 6. So you can either write it in this form, or 25 divided by 5 is 5. Root 6 divided by 6 is 1. So your answer is 5. 4 root 2 times root 3 divided by 2 root 2. So here again, that's why I prefer this method. Okay, so now I'll try and get rid of the root 2 so I don't have to rationalize. Okay. How many 2's do we have in 2, 1? How many 2's do we have in 4, 2? So our answer now will be simplified to 2 root 3. 6 root 12 divided by root 2. So 6 root 12 divided by root 2. Okay, so I'm going to write root 12 as 6 times 2 so that I can get rid of the root 2. So now, if I do that, I have 6 times root 6 times root 2, all divided by root 2. I can get rid of the root 2's numerator and denominator. So now my answer will be 6 root 6. Okay. These things, you can't go wrong. If you are good at multiplication, you cannot go wrong, okay? Because you can easily see what you want to get rid of, and then you do that. Okay, today we are going to look at probability, more tree diagrams. These are dependent events, okay? We have independent and dependent events. This is an example of a dependent event. Audrey has 15 sweets in a bag. 6 are red, so the probability of Audrey choosing a red is 6 out of 15. The probability green, 9 are green, so the probability of choosing a green is 9 out of 15. They won't give you this part in the question, but I guess by even seeing that helps you. So if the probability of a red is 6 out of 15, the probability of not a red is 9 out of 15, because you need to take away 1 out of that. If the probability of choosing a green is 9 out of 15, the probability of not a green is 1 out of 1 minus 9 out of 15, which is 6 out of 15. Okay, so you either choose a red or a green. Okay, I have done this in the earlier video. What I just said, I just thought I'll throw it in there. Okay, now Audrey removes a sweet at random from the bag. It notices color but does not replace it. That is why it's independent. She takes a sweet out. She didn't use it. She didn't give it out. She didn't eat it. She knows the color and then replace. Represent all trace information on a tree diagram. So this is the first choice. Red is 6 out of 15. Therefore, green will be what? 9 out of 15. You can reduce it or leave it in this form. Okay. Now, the second choice, okay, she replaced it. Okay. Oh, she does not replace it here. So now she takes the second one. The first one wasn't replaced. Okay. So there is it says here not replaced, that one. Okay. So now we have 14 in the bag. Okay. So there are 14 in total. If she picked a red, now there'll be 5 red. So the new probability will be 5 out of 14. If she picked green, okay, if she picked red, so there's still 9 green. Total over 14 because she didn't replace. Okay. Now, green, 9 out of 15. That is the total in the bag. If she will pick green. Okay. But if she goes ahead and pick red, because she's not replacing, there are 14 in the bag and then 6 red. Okay. If she's going to pick green, she's already picked 1 green. So green is reduced by 1. Okay. So now she has 8 out of 14. Okay, if the second is done. So I have extended the tree diagram. The probability of a red and a red. First red and then not replacing second red. So it will be 6 out of 15 times 5 out of 15. Okay. How many 5s do we have in 5-1? How many 5s do we have in 15-3? How many 3 do we have in 3-1? How many 3 do we have in 6-2? Okay, now 2 here. So how many 2s do we have in 2-1? How many 2 do we have in 14? 7. So the probability reduces to 1 out of 7. Okay. You can multiply through numerator and denominator, but it will be bulky if you don't have a calculator. Or you can cancel out and reduce it further to 1 over 7. You can go and try it and see. The probability of a red first and a green. So here, red, 6 out of 15. Green, 9 out of 14, which is here. So if you reduce it further, you get 9 out of 35. Guess by using factors. How many 3s do we have in 9-3? How many 3s do we have in 15? 5. Okay. How many 2s do we have in 6? 3. How many 2s do we have in 14? 7. So we have 9 out of 35. Now a green first and a red. So a green 9 out of 15 and a red 6 out of 14. So I've reduced the 9 out of 15 to be 3 over 5. So 3 over 5 times 6 out of 14. Okay. So here again, how many 2s do we have in 6? How many 3s do we have in 6 too? Okay. and then we have 7 here. How many twos do we have in hold on, hold on, hold on, hold on, hold on. Let's go back and check. Okay, that will be 6. So 18 out of 5 times 14. So let's see again. How many twos do I have in 6? 3. How many twos do I have in 14? 7. Okay, so I think that will be 3 here. This one here, this is 3. Okay, these are things you can easily do, and then that will be 9, because 3 times 3 is 9, and then divided by 35. Okay, so green and a red is 9 out of 35 here. Okay, not 6 out of 35. Okay, please note, you can go and do the math yourself, and you realize it's 9, not 6, please. Okay, now probability of green and a green. So here again, green is 3 out of 5, and then another green is 8 out of 14. So here again, 9 over 15, which is the original one, before I reduce it, then 8 out of 14. So now, how many 3s do we have in 9? 3. How many 3s we have in 15? 5. How many 2s do we have in 8? 4. How many 2s do we have in 14? 7. So the denominator is 5 times 7, which is 35. The numerator is 3 times 4, which is 12. Okay, so this is why you shouldn't be quick to give your paper out. Okay, try and go over your work, because something like this, even though you got your tree diagram wrong, right, just by missing 6 and writing 9, you have got the answer wrong, so you end up with a half mark or 1 mark off. You want to collect all the marks as possible. Okay, that's why you should also follow my notes. Okay, so that is the first one. So that one, I just did the tree diagram. Audrey's 15 sweets. I did the diagram. It's not being replaced, so I showed you how to do that. Now, there's another one here, which I want to quickly show you before we leave today. Mark and Simon ran a race and swim. Okay, so they both ran a race and they swim. The probability of that Mark wins the race is 0 out of 0.4. Okay, here they are giving the probability in decimals. Therefore, Mark, if Mark loses, it will be 0 out of 4 out of 6, because if you add 0.4 plus 0.6, you should get 1. Okay, the probability that Simone wins in swimming is 0.7. Okay, so if she's not going to win, then it's 0.3. That will be her losing in swimming. This part and that part was not given. Okay, I had to analyze it and insert that. So as you are reading the question, these are things you should be noting down, because you need it if you want to do a tree diagram. So in the first is that complete a tree diagram for this information. Okay, use the tree diagram to find the probability that Mark wins both race and swimming, the probability that Simon loses the race but wins the swimming. Okay, so she won't she loses the race but wins swimming. So let's see what I did. So first is the race. Okay, for Mark to win is 0.4. So if Mark has 0.4 probably win, then Simon's win is 0.6. Okay. The probability of swimming, that's the second answer. For Mark to win swimming is 0.3. Simon's win is 0.7. Because if Mark is 0.3, Simon will be 0.7. Mark's win is 0.3. Simon is 0.7. Yeah. Okay. So I've extended it further. If Mark wins, okay, and wins swimming, race and swimming, there is 0.4 times 0.3, which is 0.12. For Mark to win race and Simon winning the swimming, it will be 0.4 times 0.7, which is 0.28. For Simon to win race, okay, and then Mark wins swimming, which is 0.3, is 0.6 times 0.3, which is 0.18. There. For Simon to win the race, and then Simon again to win swimming, is 0.6 times 0.7, which is 0.42. So I have represented all this on the diagram. So I'm going to use the diagram 1 to find the probability that Mark wins both race and swimming, which is Mark wins race and Mark wins swimming, which is here 0.12. Okay, I've done it here at the back. Okay, but I'm using the tree diagram to show you the probability that Mark wins both race and swimming. So Mark will win race. We've done that. The second is the probability that Simon loses the race and wins swimming. So here is Simon. Okay, if Mark wins, then Simon will lose. So it means that Mark win, okay, and then so Mark will win. The probability that Mark loses the race and wins swimming. So Mark will have to win the race for Simon to lose. Okay, so 0.4 times 0.7, yeah, okay, which is 0.28. which I've done here for you. Okay. Simone lose and then win. Okay, so that's that. And then the probability that Simone loses the race and win, that's what we're testing. So she loses the race, okay, and then this is the only chance she will lose the race, okay, when Mark wins. So if she loses the race, then it means Mark won it, okay, and then she has to win the swimming. So that is it. The other chances are not true, okay, so that is why we can consider these other chances. So so far this is what we have to do today, okay, and if you've not subscribed already, please subscribe. Ask permission from the account holder, or just open your own account, okay, don't misuse people's accounts. Ask permission from the account holder. Okay, so here is it again. I'm showing you that one. Okay, Simone lose and wins. Okay, so ask permission from the account holder. Okay, if you don't have an account, and please follow my notes/script. Okay, this is the last two bits. Okay, there. That Simone loses. If Simone loses, then Mark wins. And the other way around is true. So assuming they turn the question the other way around, then that's what you are going to write. Okay, this one is 2 wins for Mark, when Mark wins the race and the swimming. Okay. Please beware of scammers. Take care of yourself, okay? Thank you so much for watching today's video with me, and I'll see you in the next.